not using the whole thing. We're gonna cut into like a piece size. So this is the lithium, okay? I'm gonna show you how it's easy to cut through. You should be able to see it through there. So look. I'm applying a bit of pressure, but this is a butter knife. Like imagine it's a metal, but you're just cutting through the metal with a butter knife. You see the luster, you see that shiny metal here? But then now it will change right away. It will take a bit of time and then it will change. Do you remember we talked about corrosion before? How it will corrode when it reacts with the surroundings, with the environment. So this is what's happening here. And they do corrode a lot because they do react quick. Okay, they are very reactive. Remember group 1, they are very reactive. So now what we're gonna do? First of all, I'm just gonna put a drop of this thing. It's phenolphthalein. What is that? This is to detect if we have a base in the reaction. Have you ever heard of base? You've heard of acid before, right? You know what is an acid? You've heard lemon is an acid, right? You know that? Vinegar is an acid. So all of these are type of acids. But you've never heard of a base maybe, or acids and bases, but you don't know what is a base. A base is also like an ionic compound. And where do we see base? We do use it in our daily life. Like when all our cleaning products, they are bases. They are base. Okay? You remember when we put the HCl, the hydrochloric acid, or the vinegar, the acetic acid, with that white powder? That is an acid and base reaction. Okay? So that white powder is considered as a base. And as acids can be very strong and very corrosive, bases can be too. Okay? So what will happen now when I put this metal in that, all of these are water. All the beakers that you see here, they have water in them. Please listen. So when I put that metal in the water, it will react, and the product, what will be in the beaker after the reaction, will be a base. Okay? So a base will be formed. Remember, your reactants are different than your products. You start with something, and that's why it's a chemical reaction. You end up with something new. Now, if I put this, I'm just gonna show you. I'm just gonna put a drop of this here. Nothing changed. It's water. There's no acid, no base. I just put a drop in there and nothing changed. It's still clear liquid. Okay? So now if I want you to, I'm gonna put the other piece that I'm not gonna be using. I'm gonna leave this here. And then this one, I'm gonna put it back. In the container. And they are stored in oil. And then I'm gonna put this back here. I don't need it anymore. Okay? So if I ask you to describe the physical properties of this, what would you tell me? What would you say? It looks hard, right? Look, I can push on it and flatten it. It's malleable. And the more you go down, like so now we're gonna do lithium, then after we're doing sodium, then potassium. The more we go down the group, so we go towards the potassium, you'll see it's easier. It's easier to cut through. It's easier to apply pressure on it and turn it into ash. Okay? Now this is the physical property. I'm gonna use both my hands now. One would be to hold this, and this would be used as a cover. So I'm just gonna put it on top of the beaker. I'm gonna put it on top of the beaker just in case something is, like if it may catch fire, it may explode. So just to avoid any splashes, we're just gonna put this on top of the beaker. Okay? So one hand I will be holding. Remember, this is lithium, and then I'm gonna put it in the water. And look at the reaction. It's just water. See what's happening? So what's happening? What are the size of a chemical reaction here? How can you tell that there is a chemical reaction? What do you see to tell you there is a chemical reaction?
Bubbling.
There's bubbling, yes. There is bubbling. And look, it's moving. It's moving around. How come it's moving? Am I stirring it? Is the water shaking or anything?
No.
How come it's moving around?
It's releasing gas.
there is a gas released, yes. It's a lot of energy too. It's a very active reaction. It's a very active reaction. Is it all done or not yet? How do we know that the reaction is done and it's safe to go back there and then work with it? Still, right? I still see it moving. I still see bubbling. And there is a bit of smoke coming if you see that. We're using small sizes. We're not gonna risk it and use big sizes. Because as you said, big sizes, it may break, it may cause a big explosion, it may catch fire. This is the least reactive, and you see how fast it was, the reaction. Now we're gonna move on to one that is more reactive. Okay? We did the lithium. It's all done. See? No more bubbling. Nothing. So now it's safe to remove the ghost, and then I'm gonna get the second one and try it. Okay? So what do you expect now the reaction to be? More vigorous or like less or what?
That's one way of phrasing
I'm just gonna walk it, don't be scared, that's nothing scary. And show you the sodium and tell me what can you tell me about this, about the density of sodium? What can you tell me about the density?
It's dense.
It's dense.
Why?
Because it has a low volume, which is a high mass.
Look at it. It's sitting at the bottom, right? So it is more dense. Excellent. Let me show you the lithium. I did not show you it. Look up this. It's not filled all the way from the top. Okay? So it's sitting at the top. What is that telling you?
It's not dense.
It's less dense. Okay? So this is the lithium. Guys, stop it. Okay, let's take a piece of sodium. So I'm gonna take this. The pieces are big, so I'm gonna like stab it and then remove it. Got a small piece. When I wanna keep it away from water, does it will react with water? This is easier to cut through.
Keeps it in the same position.
That's a good size.
Oh, it's sodium.
Okay, so now I'm not using this. I'm gonna put it back there.
Watch out, watch out, watch out.
Those are flammable. So when we put them in the lab,
It's gonna be like 40
we don't
minutes
store them
long.
on the shelf. There is just as like it looks like a closet. It's like a cabinet, and we put it in there. All the flammables should go in there because they should be away from anything. Okay, even if we know as teachers, we know this is flammable, but still for safety, we have to put them away. Okay, so now this is the sodium. The same idea, when you cut it, it will go back to the color. We don't see that shiny metally color because it reacts, and this reacts even faster than lithium. Okay, and you see it's, as I said, it was easier to cut through, it's easier to perceive, it's almost flat. You can't do this with the iron, you can't do this with copper, right? Just using your finger to apply, or your arm to apply pressure, or your hand even to apply pressure with a butter knife. You won't be able to turn a copper or an iron or magnesium into like a flat sheet. Okay, but you can do this with alkali magnesium. So I'm gonna take them.
In 10 minutes.
Again, it's a two-hand job, so I'm gonna get this ready. I'm gonna try to get the two of them.
Watch out, watch out, watch out.
And then at the same time.
Are you recording?
Yeah, for Wyatt.
Stuff up today. This is school. See, and I was trying to like.
This is the